In this video, we're going to concentrate on a type of code called Postnet code. Now, it is a bar code that has dark bars and light spaces. And essentially what happens is when a barcode is read, the black bar will actually absorb light, and then the white section or empty section will reflect light. And that tells the machine what you're supposed to have in that code. All right, so I want you to go ahead and take a look at the description here. Of course, binary code is any system for representing data with only two symbols. Doesn't always have to be ones and zeros. In this case, we have barcodes. So we have short ones and we have big ones. I have a document here that I'm going to go ahead and go over. It's just a little framework that's a little bit easier to read of what this looks like. When you have this code, there is two bars on the outside. So the outside bars are called guard bars. And you sometimes will hear them called frame bars. But ultimately, what we know about them is that they basically are taking the place of a parenthesis, right? It kind of contains all the information inside of it. Then when we look at our zip code, okay, our zip code is going to be our series of first group of codes. Well, what's in that code? Each of these codes is 5 bars. And it must have a very, very specific pattern. 3 of the bars must be small and 2 of the bars must be tall. And each of them are coded based on number value. So if I look at these first 5 bars and put a separator line here, I'm looking for short, short, tall, tall, or short, 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 tall, tall. That's the number 1. If I'm looking for the next group of 5, I have short, short, tall, and that's going to be 2. Then I look at the next set of 5. That's going to be short, short, tall, short. That, of course, is number 3, because this that I actually put together is the numeric, everything in numeric order. So 1, 2, 3, 4, 5. So we have short, tall, short, short, tall. That would be 4. And we can check it out here. Short, tall, short, short, tall. And then this would be 5. So that would be our 5-digit zip code. Now, often the post office will have another code, which is more specific than your zip code. So that's another 4 digits. So we just encode that just like, or read it just how we would everything else. So short, tall, tall, short, tall. Short, tall, tall, short, tall is 6. And then our next grouping is tall, short, 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 tall. Tall, short, 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 tall is 7. And then we have our next grouping, which is tall, short, short, tall, short. Tall, short, short, tall, short is 8. And then, of course, this last section is 9. Now, typically, we don't necessarily have a delivery point, but that would be a code specifically for the post office. And then our correction character, so we have short, tall, short, short, tall. Short, tall, short, short, tall. So it looks like a 4 is this one. Okay, so our correction code. So what we know about this Postnet code is that we have 5 numbers for the zip. We have 4 numbers for that additional encoding on the zip. Sometimes we'll call that +4 zip. And then we have a correction code or a correction digit. And what we know is that when we add up all of those things, it needs to be divisible by 10. All right, so let's take a look at an example. I'm going to go back over here. So let's look at this one. I have a a zip +4 code of 803210421. So 8 plus 0 plus 3 plus 2 plus 1 plus 0 plus 4 plus 2 plus 1. So 8 and 3 is 11, 13, 14, 18, 20, 21. Okay, so we have 21 on that. I'm just going to grab my calculator here just to make sure that I have the right information. So 8 plus 3 plus 2 plus 1 plus 4 plus 2 plus 1. Yep, I got 21. All right, so 21 plus my check digit has to have a number divisible by 0 or it ends in 0. So the next highest number from 21 would be 30 that ends in a 0. And so my check digit is actually going to be the number 9. So C is equal to 9 in this case. All right, now let's take another look. Find the check digit for the zip 4 code of 957313013. So again, it's 9 plus 5 plus 7 plus 3 plus 1 plus 3 plus 0 plus 1 plus 3 plus C is equal to some number that ends in 0. So 9 plus 5 plus 7 plus 3 plus 1 plus 3 plus 1 plus 3. I get 32. And the next highest one from 32 is going to be 40. And then I go ahead and erase that C and put in the value, which is going to be the value of 8. So my check digit is going to equal 8. All right. Now, let's go ahead and take a look at the other side. Because each digit is represented by exactly 2 long bars and 3 short ones, any error in reading or printing a single bar would result in a block of 5 with only 1 long bar or 3 long bars. In either case, the error is detected. The scanner ignores the guard bars at the beginning and the end and reads the remaining bars in blocks of 5 as shown below. Identify the numbers this code represents as well as the incorrect section. What should the correct value be? All right, so I'm going to go ahead and grab this code here. I'm going to take a picture of it. And I'm going to make it small so that I can reference this on this sheet. So let me go ahead and put a picture here, a little bit smaller. Oops. All right, and I'm going to stick it right over here. Okay, so let's look at my code. I have short, short, tall, tall, short. Short, short, tall, tall, short is 3. And then I have tall, tall, short, short, short. That's 0. Then I have tall, short, 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 tall. That's 7. Short, short, tall, short, tall. Short, short, tall, short, tall. That's 2. Short, short, tall, short, tall. That's another 2. Tall, short, 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 short. Right here is a problem. Only 1 tall. Okay, so that's my error that I have. And let's go ahead and finish the rest. So tall, short, tall, short, short. So that's 9. Tall, tall, short, short, short. That's 0. Short, 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 tall, tall. That's going to be 1. And then tall, short, 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 tall. That's 7. Okay. So 30722 something 9017. All right, so let's take a look at what the question is asking us. Identify the numbers this code represents as well as the incorrect section. What should the incorrect value be? All right, let me move this over here. Well, we know that all of our codes add together to be divisible by 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 plus 0 plus 7 plus 2 plus 2 plus x. I'm just going to put an x in there for it. Plus 9 plus 0 plus 1 plus 7. And so this is very similar to what I was doing on the other ones. So I have 3 plus 7 plus 2 plus 2 plus 1 plus 7. So I have 31 plus x is going to give us the next one that's divisible by 10. So my x is going to equal 9. All right. So it's not my check code. My check code is 7. So therefore that number has to be 9. And then the shape of the 9 would be tall, short, tall, short, short, short. So tall, short, tall, short, short. So that's the number that's giving us a hard time. All right, suppose the barcode for the first digit of zip plus 4 code has 3 long bars instead of the required 2 long bars. If the remaining barcode for the last 9 digit, including the check digit, represents 505582721, what is the correct first digit? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, I'm just going to go x plus 5 plus 0 plus 5 plus 5 plus 8 plus 2 plus 7 plus 2 plus 1. And let's see what we got. 5 plus 8, 2 plus 7. We have 35. So x plus 35 equals, and we're going to say 40 because that's the next one up. So then x is equal to 5. So that should be my answer. All right, let me go ahead and move this again. Create a barcode for the zip code 36801-0705 and find the check digit. Well, let's just go ahead and find the check digit first. So my check digit is going to be 3 plus 6 plus 8 plus 0 plus 1 plus 0 plus 7 plus 0 plus 5. So go ahead and put those in your calculator. And I got 30. 368100705. I got the number 30 before I even used my check digit. So that means my check digit is going to equal 0 because I can't do a check digit of 10. All right, so I've got that. Now let's go ahead and find our actual barcode. So I'm going to push this up here so we can draw it. And so I have 3. I have to put my guard bar, right? So that's going to go down. And then 3 is going to be short, short, tall, tall, short. Short, short, tall, tall, short. 6 is going to be short, tall, tall, short, short. Short, tall, tall, short, short. 8 is going to be tall, short, short, tall, short. Tall, short, short, tall, short. O is going to be tall, tall, short, short, short. 1 is going to be short, 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 tall, tall. Short, 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 tall, tall. And then 0 is going to be tall, tall, short, short, short. 7 is going to be tall, short, 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 tall, short, short, tall. 0 is going to be tall, tall, short, short, short. And then 5 is going to be short, tall, short, tall, short. Short, tall, short, tall, short. And then I have to put that last guard bar in. So this is actually what your code would look like on that envelope. All right. So we've gone ahead and gone through some example problems here of Postnet. And I want you guys to go ahead and work on 8.2 practice. Okay. 8.2 practice. And then in our next video, we'll do the encoding personal data using the SoundX coding system.